last problem, we want to find any relative extrema. So we're going to take what we just got done doing, because we've got some inverse trig functions, but we're going to bring it back to chapter, I gotta think what chapter that was, chapter 3, when we were talking about relative extremas. And remember how we find relative extremas, we have to find the derivative and set the derivative equal to 0. So, step 1, find the derivative. Alright, so derivative of arc sine, that's number 19 on our rule list. My u is just x. Reminder that when you've got something written like this, unless parentheses are being used, the only thing that is considered to be inside the trig function or inverse trig function is the term right after it. So this is the same thing as saying arc sine of just x and then minus 2 after that. Okay? Unless it is in parentheses, you only ever include the term immediately following the trig function. Alright, so in that case my u is an x, just plain old x, and derivative of x is just 1. And then I have in the denominator, again I'm looking at rule number 19 for arc sine, square root of 1 minus u squared. Again, my u is just x, so that's the same thing as x squared. Then I'm going to subtract from that the derivative of this term. The derivative of 2x is just 2. So, again, how do we find relative extremas? Find the derivative. Just did that. Then we set the derivative equal to 0. Now it's just a matter of solving equations. Okay, first thing I want to do is add 2 to both sides. 2 equals 1 over square root of 1 minus x squared. Need to try and get rid of the fraction, so I'm going to times by the square root of 1 minus x squared times over here. So that gives me 2 square root of 1 minus x squared equals 1. Then I want to get the square root by itself, so I have to divide by that 2. Square root of 1 minus x squared equals a half. Now, I've got the square root by itself. I can get rid of that by squaring both sides. Again, if I'm going too fast for you at any time, pause, process, think about what you want to do. At any time, if you want to try a problem on your own, feel free to do that. Pause it, try it, and then move on. Again, it's a little different me kind of going through this without being able to see you guys working. So just don't ever be afraid to pause me as I'm going. Alright, so 1 minus x squared equals 1/4. Then subtract 1 gives you negative 3/4. Divide by negative 1 gives me positive 3/4. And that's going to give me x equaling a plus or a minus square root of 3 over 2. Alright, so now those are my extremas, but I need to decide, or possibly extremas. Those are just my critical numbers. At this point, I don't know if they're extremas or not. And even if they are extremas, I don't know whether they're minimums or maximums, so I need to figure that out. So I'm going to try negative square root of 3 over 2, positive square root of 3 over 2, and I'm going to look at some numbers bigger than that. Keeping in mind that here I'm plugging into an arc sine, and arc sine and arc cosine, if you tried to do it in your calculator, you'll find out that it doesn't work, so you'll end up figuring out pretty quickly that you can't do it. But just remember that arc sine and arc cosine, you cannot plug in numbers smaller than -1 or bigger than +1. Okay, so that's limited to that. So that's going to limit what your x's can and cannot be. So just kind of keep that in mind. All right, so I'm going to go ahead. I recognize that square root of 3/2. I'm going to quickly do that in my calculator so I know about what that is. Square root of 3/2. Whoops, don't do what I almost did. Square root of 3, close the parentheses, divided by 2. I just wanted to make sure you guys are paying attention. Alright, so that's about 0.86. So I'm going to go ahead and try out -0.9 and +0.9. You could do 1 and -1 because you can take the arc sine and the arc cosine of 1 and -1. I'm just trying to stay away from that. If you try to do anything, if you plugged in -1 or +1, that's fine. If you try picking a number beyond that, you will get an error when you type it into your calculator. Nice thing is, though, I'll go ahead and type in a 0 here. That's an easy one. And now remember what we have to put those numbers in for. So we're thinking back to chapter 3. This is why we do reviews, so hopefully it's not totally far off in our mind because we've had Extremas on reviews since then. Alright, so we're trying to plug these in. Our goal is to figure out whether the graph is going up or going down. So we're trying to figure out what's going on with the slope. Meaning, these numbers, the -0.9, the 0, and the +0.9, we want to plug into our derivative. Okay. So now plugging that into our derivative. 1 divided by the square root of 1 minus -0.9 squared. And so here you'll see what happens. And if you would have tried it, you would have seen why it doesn't work. But I'll just kind of do a little bit more of an explanation here real quick. So as I mentioned, you could plug in -1 and +1 into arcsine. Okay, but you can't plug anything less than -1 or anything bigger than 1 in arcsine. So that means the domain right here, this graph is only defined between -1 and +1. Because of that, now we're going way back to chapter 2. Getting a lot of good reviewing in this problem. Way back to chapter 2, if a graph is only defined on a closed interval, it's not differentiable at the endpoints. Meaning, when I take the derivative, I would not be able to plug in -1 or +1 to the derivative. Okay. Because at that moment, if the graph stops at that point, it's not increasing or decreasing at all. It's just done. Okay. Now, if you don't recognize that right off the bat, it's okay. You will figure it out. If you were to try and plug -1 or +1 into that derivative, okay, it's okay. What will happen is you'll actually get an error. Because if you plug -1 in, -1 squared is 1, and 1 minus 1 is 0. Square root of 0 is 0. You would have 1 divided by 0, which you can't have. So you would have gotten an error in your calculator had you tried to plug in -1. Okay, so that's why. Okay, so it's not a big deal if you would have tried it. You would have figured it out that that can't happen. But I do want you to understand why, so you don't get confused and freak out as to why it didn't work out for you. Okay, so 9, that's why I'm plugging in the negative 0.9. So 1 over the square root of 1 minus negative 0.9. I'm going to go ahead and hit enter here so I don't get my parentheses screwed up. And then I'm going to subtract the 2. Okay. You could type that all into one step, but you would have had to have closed the square root parentheses. And so I just saved myself a little bit of time, or saved myself having to make sure I had the right number of parentheses. And I get that. And all I really care about is the fact that that is positive. All right, now for the easy thing to plug in. And show you a little trick here as you're plugging in these things. So I'm going to go ahead and I'm going to go second entry. I'm going to hit that twice, so it's going to go back to here. And I'm going to save myself. I'm going to plug in the positive one here. Okay. You can retype everything, but that's just a nice little trick to redo. So I hit that, subtract 2 from that. Again, I get a positive. And I'm going to do the same thing. Second entry, second entry. Excuse me. This time, I'm going to plug in 0. And then I subtract 2 from that, and I get a negative. So it's going up, then it changes to going down, then it changes to going back up. This would be a max, this would be a min. So, coming along to that final answer, finally, we would have a max at negative square root of 3 comma 2. And I have to find the y value, but I'm going to go ahead and write this part first, and then I'll find that y value. A min at positive square root of 3 over 2. Alright, now I just need to go plug in and find that y value. Arcsine of negative square root of 3 over 2. So arcsine of negative square root of 3 over 2. We want to go ahead and get our unit circle out. And we're trying to figure out when sine is equal to negative square root of 3 over 2. Remember, our inverse trig functions are only defined in this, or our inverse sine is only defined in the first and fourth quadrant. And sine is the y values on our unit circle, so it would be negative pi over 3. So this is negative pi over 3. And then minus 2 times negative square root of 3 over 2, which is going to make that plus. Square root of 3 over 2 times 2 is just square root of 3. Alright, do the same thing, plug in here, but if you plug in a positive, that's just going to be pi over 3. That's going to be minus square root of 3. And that is it.